Hello and welcome to this 3DO webinar preview. This is a small sample of the original presentation, but if you'd like to view the full webinar, please click the link in the description below.
Hi everyone, thanks for joining us for 3DO's webinar, High Performance Metal 3D Printing, a Metallurgical Perspective. My name is Lance Coleman. I am the Vice President here at 3DO. And we thought this was an important webinar to do because the challenges we face in metal 3D printing going to production are very similar to all the other metal 3D printing technologies. And that main challenge is convincing our customers that our metal 3D printed components can be a one-for-one swap with their current parts that are manufactured using traditional technologies. So the webinar is going to focus on some recent testing that we did, and we're going to compare results from that testing using traditional ASTM testing methodologies, and we're going to compare against some additive technologies and some traditional manufacturing. So with that, we will begin the presentation and we'll dive right in. At the end of the presentation, I'm going to be joined on the Q&A by Dr. Mahmoud Chahrourieh. He is our resident chief material scientist, and he is a PhD out of the University of Southern California. So the agenda today, we're going to do an introduction with 3DO. It's going to be important for you to understand really quick who we are, what our technology is, what our specifications are that are good fits for our technology. We'll talk about intelligent layering, which is the branded name for our technology. The densification and microstructure is important to understanding the material properties, and we'll get into how we used scanning electron microscope to look at the microstructure. And we'll also use the image. We'll show you the image on that and point some things out that are pretty interesting. We'll look at surface finish, and then we'll finish with the typical ASTM testing methodologies for hardness, tensile strength, and impact toughness. We'll do a summary slide at the end, and then Dr. Mahmoud will join me for the Q&A. So introduction to 3DO. Some quick fast facts about our technology. We built this technology specifically for serial production. We weren't interested in doing prototyping. Laser sintering kind of has that on lock, as it were. It's a very effective technology for quickly building parts of all sizes and pretty much every material that you can think of. We have found that for the products that are a good niche for our technology, we can save customers quite a bit of money, and that's going head to head with CNC machining and metal injection molding, depending on the volumes that we're seeing. We don't have to have MIM quantities or the customers don't have to have MIM quantities. We're thriving right now today in about volumes of anywhere from 100 to 10,000 per month. So we're actually getting into really some interesting volumes. Our largest order today is a 42,000 piece order. Our tolerances, material properties, and surface finish are on par with CNC machining for the most part, and we'll dive into some of that today. The current material, the only one that we're offering today is 17.4 pH stainless steel. We are looking at a lot of new materials in the future, and we actually have a new furnace coming in at the end of the month that will allow us to begin that testing. But today, we are offering this single stainless steel because it allowed us to get really, really good at using it. We're not building giant parts today. We're focusing on golf ball size parts, roughly a 1-inch cube. And for first articles, when a customer gives us their CAD file and the engineering drawings, our average turnaround time, depending on part complexity, is anywhere from 2 to 4 weeks. Company overview, just a quick goal. Our goal today is to become a leading part supplier of the small and complex metal components. That's our niche. And you're not going to get to play if you don't have, if you're not competitive on cost and quality. And the traditional technologies that we typically go against are CNC and MIM, but we're going to offer those advantages with 3D printing. We are based in Los Angeles. We're in a 13,000 square foot facility. We currently have about 40 full-time employees, and we are actively pursuing and compliant with the typical ISO certifications you would expect: 9001, 13485 for medical, and then AS 9100 on the aerospace side. We consider ourselves a one-stop shop. We do everything from printing the parts to metallurgy and mechanical testing. We have a pretty robust quality department, and we take a lot of pride in that. We have a great engineering team on staff when it comes to CAD design and modeling to help try and drive costs down when customers give us their parts if any changes can be made to improve cost and function. And we have post-processing in-house, including heat treat, finishing on the surface finish, and a machine shop in-house as well to do any secondary operations beyond our current tolerance capabilities. Here's a quick overview of how the process actually works. So those are the printers there in the photo. The first step is a thin layer of metal powder is pushed over the powder bed at the depth of about 100 microns. Then a spray system comes over and sprays the entire layer of powder. This is where we differ from binder jetting, if you're familiar with that, which sprays specifically on the bed. What we do is we spray the entire layer. Once we have that bound layer of powder, a CNC micro end mill comes in and cuts out the part perimeter for that layer. That's going to cut out not just the boundary, but also any internal features or channels that are required for that layer. The process then repeats. Another layer of powder is spread over, the binder is applied, and then the cut happens again. So it's a layer by layer machining operation in the green state. Once the green parts are completed, they're put onto setters and put into a sintering furnace to sinter to near full density. And then the parts are finished, anything that might be required if there's a secondary hole or if there's any finishing or coating requirements. So just take a quick look at the 3DO's technical advantages versus binder jetting specifically. As I mentioned, since we're not jetting the powder out, we're not going to get any of the droplet effects on the green parts that you see on a typical binder jetted part. Consistent packing, the binder ratio is better, and you don't get that kind of cross-sectional area effect. If you're jetting that powder, you're going to get agglomeration, which means the particles are kind of going to be disturbed as the powder hits. Binder set expansion. When you're putting a sticky substance through a very small hole, you start getting viscosity and surface tension limitations on the types of binders you can use. Because we are not doing that and we are spraying, there's a much larger volume of binders that we can consider. And so the one we use today, we feel is superior to a lot of the different binder jetting, actual binders that they're using because of their limitations on those two requirements. And we're getting better dimensional stability for the green parts because of the lower binder content. Real quick, the intelligent part of the intelligent layering. What this breaks down to is basically if we don't have to cut every layer if for several layers it is the same shape. So also known as a 2D shape extrusion, if you want to sound a little bit fancy. What that means is after we put down 10 layers, for example, we can go cut all of them at once instead of having to cut every layer. That's also going to improve the surface finish on those sides as we do it. So deciding when and when not to do that is part of the intelligent process. Another really exciting part of doing intelligent layering is that in the upper right-hand corner there you see the hemisphere. That is one made through a traditional additive technology, layer by layer. An advantage of having a CNC end mill in the process is going to allow us to cut along the part profile and take out any stair stepping for any surfaces that are in the up-facing or accessible through a 3-axis CNC. That's going to dramatically improve the surface finish.
Thank you for watching this webinar preview from 3DO. To view the full webinar, please click the link in the description below. If you'd like to learn more about 3DO, please visit our website at www.3deo.co.